Hi, in this class we will be discussing about some of the previous year question papers regarding this APPSC examinations and also some other questions regarding TSPSC. Yeah, here it is. Some questions from TSPSC AW examination and hmws&sb examination managers, so etc. etc. So some examples and all we will discuss. Some previous year question papers we will discuss here. Okay. So first of all, let us dive into the first question here. So here in this session, if you look at this first question here, which of the following is not a casting process? Is not a casting process, they asked. Okay. So not a casting process means, so what do you mean by this casting process? So casting process involves in, so pouring the liquid molten metal into the mold cavity and then it should solidify, and then you have to take away the mold, this whatever the cast component after getting into a solidification, right. So if you look at this, centrifuge, semi-centrifuge method is a casting technique, shell molding is a casting technique, slush process is a casting technique. Okay. So we discussed all these things, right. If you look at the previous class, in the previous class where we discussed about all these three concepts here, just I wanted to show the slide here where we discussed. So centrifuge, okay. So maybe a semi-centrifuge, okay, centrifuge, semi-centrifuge. So in this investment casting and sweeping technique, okay, and in all the this technique which is called as a shell producing shell casting technique. So all these cases where we have discussed this concept here, we discussed this all those techniques where this slush casting also we discussed. Okay. So in all these techniques, these are all the casting process. Only one casting, one technique that is here left over, that is a extrusion technique. So this extrusion technique is not a casting process. So this we will be discussing, we will be discussing the considered amount of time in case of a forming process. So this comes under the concept of a metal forming concept. Okay. The rest of these three things are comes under the category of metal casting technique. Metal casting technique. So hence they are asking which is not a casting process, so it's like a odd man out. So obviously the answer is A. Obviously the answer is A. So this is the first question. If you look at the next question, in this next question they asked a question. So chills are used in casting molds to dash, okay, to achieve directional solidification, to reduce the possibility of the blowholes, to reduce the freezing time, to increase the smoothness of the casting process, all these things. Okay. If you look at these answers, so we have discussed a considerable amount of a time regarding this the concept of chills. Okay. When we discussed the concept of chills, we talked about here, if you look at the chills here, in chills we already discussed here, stating that here, for example here, so whenever there is a L-shaped component or T-shaped component or any shapes like the sudden change in dimension of the geometry, sudden change dimensions, so here there exists the concept of a directional solidification, right. We discussed this point, right. Do you recall these points here? In a directional solidification, what happens is that here, so the wherever there is more surface area, there the metal will solidify first, and leaving the some portions where there is a some corners, junctions, all these places, you will not have a directional solidification because there the surface area is very less. So to compensate here, we will be providing the chill. So we discussed all those things, details of this, why it all things happen. Do you recall this class? So if you could recall this class, you can easily answer this question. So we provide this wherever there is a junction, there we provide the chills. So because there is a concept of a directional solidification. So because of this directional solidification problem, we introduce the chills. So what happens is that here, when you introduce the chills, these chills will solidify along with that of a liquid molten metal and causing a extra material here. So this extra material can be removed out by machining operation. So this is how we do encounter the concept of chilling. Why we do is that here, we already talked about this concept regarding in the previous class, where whenever the casting is done, any metal casting is done, there is a inevitability that the mold cavity that is inside, when you put liquid molten metal in the mold cavity, there is a inevitability of the formation of the void. Okay, for that reason what we do is, because this is a directional solidification, so first the walls will solidify and then internally it will start solidification, right. So naturally what happens is that the liquid molten metal will not be supplying there, so that we are providing the riser to shift the void from cast component to the riser component. So the void is compulsory, in any case the void will form. So we will be shifting this one from cast component to the riser component. Anyway, we are not using riser, so our main area focus of the interest is the cast component. So we will chop it off and then we will take this cast component for general use or for a regular use, whatever the use we are using it. So that is how we are actually trying to achieve it, right. So in some cases here also there is a L-shaped component, T-shaped component, there we will use a chills, right. So in this problem, if you look at this problem here, you will understand the answer here. The answer is obvious, that is to achieve the directional solidification. The answer is obvious here. To achieve this directional solidification, we will be using this one. Okay. So to reduce the possibility of blowholes, so this instead of blowholes, if they have given this answer to reduce the possibility of the void, then this would also have been a right answer. To reduce the possibility of a void would be the right answer, but they have given the possibility of a blowholes. So blowholes is a casting defect. It's not a what is a cavity, that is what we can call it as a void, that is a presence due to directional solidification. Okay. So void is very different from the blowhole. So this is also wrong answer. So reduce the freezing time. So that is also wrong answer. Increasing the smoothness of the cast surface. So all these are not the right answers. Okay. So the only possibility answer is that here, which is a to achieve the directional solidification. Now let us come to the next point here. So the next point is, that is a third question. The casting method adopted for making ornaments and ties from non-ferrous alloy is dash. Okay. So it has been given in one of the previous year question paper. So usually in a investment casting is used for rocket and space application. Okay. So slush casting is used for toys or else very thin wall materials, structures, etc., etc. Okay. So the die casting is used for, so whenever you want to use a metal as a pattern material, so there use it. Okay. Centrifugal casting is used to produce pipes. Okay. So here for example, so we talked about here, so the slush casting is the obvious answer, because only specific applications only we use space applications only we use investment casting. Otherwise this ornament and all also can be produced by using a investment casting. Okay. So but actually they have given toys also, right. So the toys are generally produced in mass production. So we cannot do this as the investment casting, because the toys should be made with the cheap. The toys are always cheap and mass production needed. Okay. So because so many people will buy this one, and if it is a very costly, people will not buy it. Okay. So but ornaments and all, you can use it with investment casting. Investment casting you can produce. Okay. So here the answer is a very tight here. So mostly this question has been given to confuse you, but the answer is this one, which is a slush casting. The next question is the green sand is a mixture of dash. Okay. So the green sand is a mixture of dash. Is that, if you could recall the previous class, we discussed this one, right? So usually the green sand mixing ratio we discussed. Okay. So here in a green sand mixing ratio, silica plus clay plus water, right? So we talked about this percentage here. Silica is 70%, clay is 15%, water is the rest of the percentage, right? So remember that here the silica is almost 70%, and rest of this is that clay, water, etc., isn't it? So if you could recall this one, then obviously you can go for this answer. So which we discussed already, we have discussed this in class. Okay. So the sand is 70%. So sand is minimum 70%, right? So you cannot change this one. So rest of the percentage, whatever it is there, so that is obviously here. Okay. So but here the answer is a partial answer here. So they have listed everything under the 30% clay. So the answer is obviously C here. Answer is obviously C. So sand cannot be 30%, sand cannot be 50%, sand cannot be 90%. Okay. The next question is a casting defect which occurs due to improper venting of sand is also known as dash. Okay. So whenever we discuss this casting defect, please try to remember the concept we discussed here, which is here this diagram. So okay, this is one diagram where we discussed everything in detail, right? So here we discussed the concept regarding this what we call just before what we talked about here. So here one of the casting defect where it is here, the question is here, defect which occurs due to improper venting of the sand. Okay. So if you look at this improper venting of the sand, okay. So the improper venting of the sand is due to blowhole. Okay. So we can call this one as a very first category here, the very first category of the this one. Okay. So air bubble, so improper venting, this is due to air bubble did not fully get away from the liquid molten metal. So this is due to you have not given after making a mold, you have not put a venting for the free air to pass very easily. Okay. So such cases will have this problem here. So this is called as a blowhole. This one is due to blowhole. Okay. This is due to, we discussed this one. So improper venting causes blowhole because here the liquid molten metal didn't have sufficient time for solidification to take place. As a result, the air bubbles didn't come out of the liquid molten metal. So this is the reason. Okay. So obviously the answer is a blowholes. So the next question is, here sweep pattern are used for the molding parts having the shape of dash. Okay. So sweep patterns are used for the molding parts to have the shape of dash. Okay. So when you use this sweep pattern, what will happen? Okay. See, it's not a defect sweep patterns. So it's all they have given is a cold shed, blowhole, shift, swell, all these things, right? So if at all you are using sweep patterns, the molding patterns will have what is the shape. Okay. So if at all they have a, we just go through the slide in the previous class where we discussed the sweep pattern. So when we discuss the sweep pattern here, so there will be a central axis. For the central axis, we will take a potting plate and then we will turn it, right. So here if at all they produce any defect, so it can form only the swell here. So that is the answer here. Okay. So the answer would be this one, not this one, this one, this one. Answer would be the swell. So that's the only answer here. So the next question is this one, ornaments. See, 7th question, ornaments, statues, toys are casted by the following process. Okay. So if you remember just if there is a word called as toys, remember it's only can be done by using a slush casting. So the die casting can be done, continuous cast can be done, centrifugal casting only used for pipes, okay, not for everything. Mostly centrifugal casting will be using only for pipes, okay. So ornaments, statues, these are all delicate items, right. So there is only one obvious answer, that is a slush casting. Now let us have this one more question. So the identify the odd man out in the casting process. In this casting process, so it has been given a TSPSC in AW exam 2015. So what is this odd man out? You see, the chills are used for a directional solidification. Paddings are also used for to arrest the flow of the molten metal. Inoculation is also something which is related to the molten metal itself. Okay. Only one thing which is different is that here it is a loam sand. So that is a loam. So rest of the things are related to metal. Or liquid molten metal. This is only related to sand. So that's why we have to identify this one. Okay, so it's just a normal common sense question. Then chills are not used. See, you have to remember here. Read the question very carefully. The chills are not used in the following application. So in the previous question, they gave a question that chills are used for following application. If the chills are used, then directional solidification is obviously right answer. Okay, you can see that here right now they are not used. No, so this is the wrong answer. Then smaller castings for erectoid steels, that also we don't know. Change in cross sections. Okay, complex geometry. Okay, the chills are used for all these things. So the chills are used here because of directional solidification. The chills are used for directional solidification. The chills are used for change in cross sections. The chills are used for complex geometries. So for all these reasons we are using. Okay, there is only one obvious answer here, smaller castings for eutectoid steel. So this is not there. So this is the right answer for this question. Okay, so this is like a odd man out question. Next question, hot tear. Hot tear is dash, is a physical property of a non-ferrous material, is a physical property involving heat, is a phenomena occurring in material exposed, right, and is a defect in a casting. So is a physical property of non-ferrous material, is not just only for non-ferrous material, both the ferrous and a non-ferrous material, this is there. Okay, so this is the wrong answer. Then is a process involving in heat? No. This is due to, hot tear is due to solidification. So is a phenomena occurring in the material exposed? So that is also not reason, right? Obviously this is a defect in casting, but you just recall the slide here in the previous class where we discussed about hot tear. Okay, hot tear is due to when you pour the liquid molten metal. So because of this improper solidification concepts, what will happen is that they will develop a bulk buckle inside the material itself. So this is a hot tear. So this hot tear is due to a phenomena, one of the casting defect. So you should remember here, this is a casting defect, one of the casting defect. So obviously the answer is D is the right answer in this question. Okay. So the next question is, cores are used. So cores are used in a symmetrical casting only? No, it's not like that. Cores are used to get a smooth surface in on casting? No. The cores are used to get a cavity or recess in the cavity. Partial answer is there, to strengthen the mold. So this is wrong, not a wrong answer. You see, cores are used whenever you wanted to manufacture a halo shaped components. We use cores. Okay, it's not because of symmetry. So we can actually introduce a cores even in a non-symmetrical casting also. Okay, so this is wrong. Okay, this is wrong. We can use a symmetrical, asymmetrical also can be used. Okay, so no issue. So it's all depend upon where you want to produce a halo shaped component. The halo shaped component may be exactly a symmetrical or asymmetrical, or it can be a non-uniform also. Okay, so it is not dependent. So cores are used to produce, to get a cavity. That's the right answer. Or we can call it as a recess in the cavity. That is also right answer. The next question, in a dash, the following the molten metal is poured and allowed to solidify while the mold is revolving. Okay, so mold is revolving and liquid molten metal is poured, and then right. So in a die casting technique, we use metal as a pattern. Metal as a pattern. So this is not right answer. Okay, slush casting is used for making a small or thin walls, thin wall materials. Okay, so the permanent mold casting technique is used for normal technique. So this is also not wrong answer. Okay, so the only obvious is the answer is a centrifugal casting. In centrifugal casting, the mold will be revolving. Mold will be revolving. So this is the right answer. Okay. So for this, you should recall the previous class where we discussed in the previous class. In a centrifugal casting, we discussed this concept regarding. So we pour the liquid molten metal. The mold will be continuously revolving. Right? We take away this liquid molten metal. This whatever the cast component is there, we take away from the other side. Right? So do you recall this? This one. Right, so that is so we take away the pipe can be extruded from one side. So this is where we manufacture the component by using a centrifugal casting. So that's the question here. So the answer is obviously centrifugal casting for this question. Okay. Next question is, shift is a casting defect in which dash? So we discussed this topic regarding the casting defects. Okay, if you could recall. So that it results in mismatching of the top and bottom parts of the casting, results in general enlargement of the casting, then occurs near the ingates and the rough slabs. So on is this also not wrong answer. So occurs as sand patches on the upper surface of the casting, this is also wrong answer. Okay. So we discuss this shift here. So whenever this shift is going to take place, the shift is going to take place. Say for example, this is a pattern material. So if you are not properly mismatching these patterns, so the shift will take place here. So this is actually the diagram for is one of the casting defect. So that's the answer here. Results in mismatching of the top and bottom parts of the casting. So this is the top part and this is the bottom part. So when it has two patterns, okay, when patterns are two components, so when the cope pattern and the drag pattern, they are not aligned properly, then you will get this type of defect. Okay. The next question is, core in the centrifugal casting is made of dash. Okay. So in a centrifugal casting, what happens is that here we will not use core at all, not a carbon wax or anything. Okay. Centrifugal casting is based upon centrifuge force. Okay. So just before only we discussed that there is a mold here, it will be continuously revolving. Okay. So the liquid molten metal is brought here somehow with some technique, and then continuously we produce these pipes here. Okay, pipes are extruded here in this manner. So here there won't be any core here. Okay. So the liquid molten metal will, because of the centrifugal force, it will go and touch on the walls of the extreme pipes here, and then that's where we will be plucking out the pipe here. Okay. So that's why we manufacture this usually centrifugal pipes. Okay. Next question, the collapsibility of a green sand mold can be increased by adding. So collapsibility. Okay. So if you add water, it will stick more. Okay. So this is also not a right answer. If you add clay, then also it will stick more. So this is also not a right answer. If you add synthetic resins, all those things also, what happens, it will actually stick here. Okay. So the collapsibility is something, it should not stick. Okay. It wanted to become a powder, right? So obviously the answer is this one, which is the wood powder. Okay. This is like a odd man out. The next question is, in a gravity feed system in casting, the cross-sectional area of a horizontal runner is dash. Okay. So in a gravitational feed system, so this in a gravitational system in feed system means normal casting system. Okay. So the cross-sectional area of horizontal runner, so it does not depend upon cross-sectional area of horizontal runner. So this always remains same. So it does not affect any one of these concepts. Okay. So there is no any link between the normal casting and the horizontal runner. So there is no any link. So it's like a odd man out question. So obviously the answer is a which remains the same. The next question is, if only one product is to be made, what should we adopt? Okay. So only one component. So the die casting is a metal. So obviously this is used with metal pattern. So obviously we have to use it for mass production. Continuous casting also same thing will be produced. So, mission molding also we employ for mass production. Okay. So, there is only leftover option is sand casting by hand. So, because we can do it for only one go. So, again we need to make it again further, right. So, for that to manufacture another component, again we need to make a sand casting, and again we need to make a mold, everything under cavity, everything we need to make it, right. So, that is a only obvious answer. The next one is in gate patterns, only gates are built into the pattern. No gates are made into the molding sand. No runners are made in the molding sand. Gates and runners are built in the pattern itself. So, this is the right answer. So, these are all something like nonsense answers. So, there is no meaning of these answers. Okay. So, the gates and runners are built in the pattern itself. So, in gate patterns, gates and runners are always built inside the pattern itself. So, that is the answer. And coming here, next question is, during the freezing of a pure metal, the possibility of a casting structure is dash. So, we discussed this point here in the very beginning class, very first class. If you could recall this one, when we talked about the concept of this freezing and all these things, right. So, if you could recall here, when there is a freezing is going to happen, right. So, this pouring we are using a impure material, right. So, we are using a pure material. So, if it is a impure material, it will have some time latent heat of fusion, all those things. If it is a pure material, it will freeze directly, right. So, directly it will freeze to the normal room temperature without any change, considering of a latent heat of fusion, latent heat of vaporization, all those things, right. So, when it happens like this, we also talked about the concept regarding the formation of a dendrick structure. Okay. So, I would like to show the slide here where I would like to recall here in the slide itself. Yeah. So, any other place? Yeah. Here in during solidification, so when you pour this pouring temperature, it will slowly come here. It takes in 3 stages. Otherwise, it takes in a single stage. So, this is due to this pouring the heat temperature, the sensible heat is going to take place, latent heat is going to take place, and in 2 times of sensible heat is going to take place. So, during this time, because of this infinite wall thickness, everything, so you will have a long columnar structure, dendrick structure, right. So, that is the structure that actually here they are asking about in this question, here in this last question. So, the last question is, this is a partly columnar and equiaxed, no. So, long columnar structure, yes. Dendrick structure, no. Equiaxed grain structure, no. Okay. So, this is the case regarding this answer regarding during freezing time, freezing of a pure metal, the possibility of casting will be a columnar structure. So, if there is no impurity, the grain will be very long. If there is impurity, the grain will be a very small grain. That is the answer here. Okay. So, I hope you understood regarding the concepts that we discussed in the class and how we have correlated it into the here. So, how we have correlated to these questions. Okay. So, if you follow the class and listen to the all videos which are discussed in the class, it is obviously very easy for you to face the examination, and all the concepts, topics, or even simple minor problems also has been discussed in the class itself. So, to face this examination, you have to do, what you have to do is, you need to look into the previous year the class videos and then follow our institution notes and materials. So, obviously, if you do this, definitely you can crack the examination. So, I hope you understood the concepts regarding this previous year question papers, and I wish you will prepare well and get a very good position. Thank you.